third type of reaction that we are going to be studying in this unit, and that is single replacement. And so if you notice what I've included in this video, what you have on your page 12 of notes, which this is, here is your kind of formula for single replacement, and you'll actually see it's really not necessary once I go through and explain a little bit about single replacement, but here it is for you anyways. All right, and then below it is your activity series, and that's going to be included in, well, it's in your packet right now, and it's going to be included in your cheat sheet as well that you guys get on a test, and I'll explain what you use that for in just a little bit. All right, so we're going to go through. Remember, for single replacement, what happens is one atom, so you have one element all by itself and a compound, and what happens is that one element will kick out another element, and what you get as a product is a brand new compound, and the original element that was in that compound is going to be all by itself now. All right, and so here are a couple things that we need to talk about. First of all, positive ion, which we also call a cation, okay, is always going to switch with, well, let's look at this. If you have a positive and a negative here, all right, if A is positively charged, the only thing it can kick out, the only thing it can replace is another positive charge, because what it now forms with is, so C has to be a negative anion, right? Because if A were to kick out, let's say C, you would have a positive charge and a positive charge together. That's impossible to have. So A has to kick out a positive charge if A is positive. All right, so if A is positive and B is positive, A is going to kick out B. All right, so a cation will always switch with a positive ion. Let's look at the reverse of that. Now, if you have a negative ion, which we call an anion, okay, it's going to switch. So let's look at an example here. If D is negatively charged, all right, it's going to kick out another negative charge so that when you form your new compound, you've still got a positive and a negative. Because if D were to have kicked out B, you would have had a negative and a negative, and that's impossible to have. You always have to have a plus and a minus charge together. All right, so it has to switch with a negative ion. So that's just something to keep in mind. If you have a positive element, an element that has a positive charge naturally, it's going to kick out a positive ion. If you have an element that has a negative charge, it's going to kick out the negative ion. Okay? We're gonna look at this a ton in this unit, so don't worry about it. But let's look specifically at a couple more things before we get started. Okay, which is written first in a compound? Well, if you look at it, remember, you have your plus and then your minus. So your positive ion is always written first. Okay? An element will only replace or kick out another element if it is, okay, here is where your activity series come in. An element is only going to kick out or replace an element if it is higher up on the activity series. So if I were to ask you the question, will potassium kick out lithium? Okay, so if potassium were to come along and try and kick out lithium, okay, you would say no, because potassium is lower on the activity series. And we're going to look at that in more examples, but it has to be higher up on the activity series. And that is the purpose of the activity series, to tell you whether or not a reaction will occur. Okay. If it's not higher up, if the thing that's coming along, so if A is coming along, if it's not higher up than B on the activity series, it cannot kick B out. Okay, it's not active enough to kick B out. And if it's not active enough, then we write no reaction. All right, so let's look at a couple of these. I've got magnesium and zinc chloride. So first of all, think about magnesium. What charge does magnesium naturally have? And what you should be saying is, well, it's got a +2 charge. So magnesium, since it's got a plus charge, it's going to want to kick out the other positively charged ion, and that's zinc. So I like drawing arrows just to help myself. So magnesium is going to come in and kick out zinc because they have the same charge. All right. And what we have to do before we write anything else is decide whether magnesium can truly kick zinc out. And the only way magnesium can kick zinc out of the compound is if it's higher up on the activity series. So let's look at this. Here's magnesium, and here's zinc. So yes, in fact, it can. Magnesium, since it's higher up than zinc, it can kick zinc out. And so what it's going to do, it's going to kick zinc out all by itself. So I'm going to write out zinc all by itself. Okay. And now magnesium is going to form a compound with chlorine. Okay. So now you need to make a compound that has magnesium and chlorine. Okay. Magnesium has a +2 charge. So I'm going to do this off to the side because most of you are probably doing this in your head, I'm hoping. And chlorine has a -1 charge. So if you cross your charges, what you should get is that you get magnesium MgCl2. All right? So I've just created my product. You now have zinc kicked out. You have an element plus a compound. So if you notice, for single replacement reactions, in order to identify them, if I were to mix all of the reactions we've done together, if you see an element all by itself plus a compound, automatically in your head you should be thinking single replacement. All right, so let's look at another example. I'll do one more of the typical one, and then I'm going to do a little bit more of a tricky one. All right, so here's Ag plus KBr. So Ag naturally has a plus charge. It has a positive charge. So Ag is going to kick out Kb since K has a positive charge. All right, so let's check to make sure Ag can do that. All right, so where's Ag? Oh, Ag is all the way down here, and K is way up here. So since Ag is below K on the activities series, Ag cannot kick K out. All right, it has to be higher up on the activity series. So I'm going to write no reaction, and I'm done. All right, let's look at another example that looks a little daunting, but it's still totally, you guys can totally do it. If you notice Cl2, it doesn't look like an element, but remember it is. Since it's just Cl2, you have only one type of atom here. Cl2 is still considered an element, and this is a compound. All right, but remember, Cl has a minus charge, so instead of kicking out magnesium, which you would expect, it's actually going to kick out fluoride. So chlorine's going to come in here and kick out fluoride. So if you notice, if you go searching here on your activity series for chlorine or fluorine, you're not going to find them. Where you should be looking is right here. All right, so here's Cl2 and here's F2. So can Cl2 kick out F2? No, it can't, because Cl2 is below F2 on the activity series. So you're not going to have a reaction. You're going to say no reaction. All right. I'm going to do a couple more with you. Okay. I'm going to do this one, for example, with you. All right. So here's Br2 and BaI2. So remember, Br is going to be replacing one of these two. So first of all, you have to think, Br, what's the charge of Br? And you should be thinking Br has a negative charge. So it's going to be replacing the I. So I'm going to draw an arrow to the I. All right, so let's look here. Is Br higher up than I? Yes, it is. So I'm going to kick I out. Okay, and I can't just write I like this. I'm going to write it as I2, not because there's a 2 here, not because I'm trying to balance, you're not allowed to do that, but because I all by itself is not stable. It's a diatomic element, so I have to write I2. All right, plus Br has replaced I2, so I now need to write a compound as Ba and Br. So if I come over here and write Ba with a 2+ charge and Br with a 1- charge, cross my charges, I would get the compound as Ba, Br2. All right. So what I want you to do right now, pause this video, work on 5, 6, just 5 and 6 right now, and then I can walk you through the next couple of ones really quickly. Okay, so just work on 5, 6. Pause it right now. All right, let's look at 7 really quickly. I've got magnesium and HCl. So if you think about it, magnesium has a plus charge, right? H has a plus charge, so magnesium is going to be kicking out the H. All right. So here, the funky part, guys, here's your H here, and then your magnesium is here. So it's your job. You now need to determine whether magnesium is going to kick out H. All right, and then determine your products. Okay, so I can help you a little bit. H is going to be kicked out. But can I just write H like this? And I can't because it's diatomic, so I'm going to put a 2 there. And then Mg is going to replace the H, so it's going to be Mg. And at this point, guys, I'm going to just stop crossing charges. If you're having issues, you need to come in. MgCl2. And I'm done. Okay? I'm not balanced yet. I'm going to ask you guys to do that on your own. All right? I'm going to have you do a couple more on your own, but really quickly, I'm going to give you a little bit of a hint for 8 and then have you do it on your own. All right? Another way to write H2O is just to write H-O-H, because you got 2 H's and 1 O. So Ca can come in and kick out that H and form a molecule with the OH and have kicked out H, just like up here. So treat OH just like Cl, and you can find your products just like that. So what I want you to do now, complete number 8, 9, and 10, and you can pause this video right now. All right, we've got one last task to do. The other thing that this activity series really nicely does for you is it tells you how metals are going to react with different states of water. So if you look here, it says replaces hydrogen from cold water. So these, within these arrows, guys, these metals are so reactive that they will replace the hydrogen from water. So they will kick out that hydrogen and form with the OH with cold water, because cold water is your, we'll talk about movement of molecules, but that is it's basically the hardest to react with cold, something that's cold. Hot substances are the easiest to react with because your particles are moving so fast. But what this is saying is that within these lines, these elements are so reactive that they will react. So all I'm asking you to do is say whether the reactions will occur. So will lithium react with cold water? So what you need to do is look here and decide whether or not lithium is within this range of reacting with cold water. And it actually is, because it's at the top. So I'm just going to put a yes or a check mark or whatever. All right? So if you notice all of these, here it says reacts, replaces hydrogen from steam. Here it says replaces hydrogen from acids and sorry, what does that say? I think it reacts with oxygen from oxides. So just answer these questions. If it's within this range, right? So I can answer one more. I'll do number 3 with you. It asks if iron will react with steam. All right, so it needs to be within this range. So if iron is within this range, then it will react. And if you notice, it is, because it's right here. So there's another yes. Okay. So once you've completed these last 3, then you can be done. All right. Great job, guys.